forecasting with the linear model. Here we are going to use the linear model to forecast. These are the data variables, the data values of the variables hours and score. Hours is the explanatory and score is the response. We used the formula, these formulas in a previous video to calculate the correlation coefficient and also the gradient and the y-intercept for these data values. We used Excel and Excel spreadsheet. Here it is. And we got the slope to be 1.2 and the y-intercept to be 34.77. This was verified using a scatter plot. Go to insert, scatter, and here you have a scatter plot. And we went to quick layout, and layout number 9 shows the following chart element, the chart title, the legend, and also the series and the horizontal and the vertical axis, and also the equation of the line of best fit. Here is the linear model. The slope is 1.2, like how we calculated, and the y-intercept is 34.77. We know the interpretation of the slope is such that whenever the hours increases by 1, the score increases by 1.2. So that is the interpretation of the slope. Whenever the x variable increases by 1 unit, always 1 unit when you're interpreting the slope. So the x variable here is hours. So whenever hours increases by 1 hour, every 1 hour you study, your score will increase by 1.5%, 1.2%. So that's the interpretation of the slope. Now, the interpretation of the y-intercept, it means that if you do not study at all, most likely you might score 34.77%. So that's the interpretation of the slope and the y-intercept respectively. And we are going to use that now to forecast. So we're going to complete the linear model in our worksheet. So score is equal to the gradient, the slope is 1.2. (1.2) times hours. As we see, the 1.2 means that every time hours increases by 1, your score increases by 1.2. And it starts at 34.77. If you don't study at all, you are most likely to receive 34.77%. So if you study for 2 hours, then it will be 1.2 times 2. If you study for 1 hour, it's 1.2 times 1, starting with 34.77. So that's what the model is saying. If you study for 3 hours, it's 1.2 times 3 plus the 34.77. And so if you would like, if you study, for example, for, let's say your hours is equal to, let's say you study for 12 or for 12 hours. Let's say h is equal to 12. Then remember, if you study for 1 hour, your score will increase by 1.2. So if you study for 12 hours, you just substitute 12 into the linear model in the place of hours. And then you calculate. You can use Excel to help you do that. So here we have equal 1.2 times 12 plus 34.77. And if you study for 12 hours, according to this, your score will basically be 49.17%. Now, if you would like a score, let's say, of 90%, let's say you want a score of 90%. Let's say your score is equal to 90%. You want a score of 90%. How long should you study if you want a score of 90%? Basically, what you do, you substitute 90 in the place of score. Because the score is 90, and now we're going to solve for hours. We subtract 34.77 on both sides because we're going to make hours the subject of the equation, subject of the model. So this plus 34.77 becomes a minus. So we're going to calculate 90 minus 34.77. Can do that right here in Excel. Equal 90 minus 34.77. That's 55.23. And now we are going to divide both sides by 1.2. 55.23 divided by 1.2. And 1.2 divided by 1.2. The 1.2 cancels out. And 55.3 divided by 1.2, we can easily calculate this in Excel again. Equal 55.23 divided by 1.2. That is 46.05. So if you like a score of 90%, according to these data values, you must study for 46.25 hours. Now, it is important to note that when you are using the linear model to forecast, always try to use values within the range of values. So we see we use 12, which is between 10 and 51. You see we use 90 because it's between 45 and 95. So if you would like to forecast using values outside of the range of data values that you use to calculate these statistics, then you must do another research, try to get values within that range, and then do your recalculation, because it is very inaccurate to use values outside of the range of data values that you use to calculate the statistics of 1.2 and 34.77 in the first place. So we use 12 for hours because 12 is within 10 and 51, and we use 90 for score because it's between 45 and 95. So here we use this model to calculate score using hours, and we also use it to calculate hours using score.